So we're going to learn two new symbols today, and the first one has to do with an intersection of two sets. In fact, it's the intersection symbol. And the intersection of two sets, set A and set B, and what is a set? A set is just a grouping of numbers for some reason or objects. Like I have two sets of students right now for my class. I have this set of students. You could say my whole class is one set of students. I could say I have a set of students that is listening to the lecture today, right? You guys are on Zoom with me. That's a set, right? You're in a set, your set of people, and you have like a common purpose, maybe, or a common objective. Like you could have a bag of marbles. That could be a set, right? So that's what a set is. It's a grouping of different information, different objects, numbers, letters. So you could have two different sets, A and B. And an intersection is the set of elements. An element is an object in the set, common to both sets. A intersect B, now this is the new notation, is denoted by, we would write A. This is the intersection symbol, is like an upside down capital U. Okay, an upside down capital U means intersection B. So we say that, we specifically say and read that as A intersect B. Now, there is a little diagram in front of you. If that pink circle with A in it, that represents all of the elements in A, the set of A. And the blue circle represents the set, all of the elements of B. The symbol A intersect B is going to be the elements that overlap, the elements that are in both sets. So let's take a look at an example. And one way to represent sets, is with set notation, these curly brackets right here. Curly, we call them curly brackets because they're not just parentheses, right? They have a little movement to them. So when I see this set and it says sets A is equal to the values or the letters A, B, C, D, E, F. Each of those letters is an element in A. Each of them is an element in A. Okay, and so that makes up the set A. When I look at B, and it is equal to the set A, C, E, G, I, K. Those are the elements in B. Okay, that is the set B. And then we have C, a set, and C is the name of the set. Okay, and is equal to curly brackets. So those are the elements G, H, I, J, K. And we want to find the following. The first one is we want to find A intersect B. Well, I'm going to go ahead and draw. By the way, this is an example of a Venn diagram. I'll write that down there. That is an example of a Venn diagram. And we can use Venn diagrams to help solve questions, okay, and also represent different sets. So for this one, I'm going to go ahead and I'm going to write, this is just my box, and then I'm going to write here in my two sets. This is set A, okay, and this is set B. And I'm going to use these values in the set. All right, now notice that both A, little a, is in both sets. So little a, I'm going to write right here, A. I'm going to write this little a right there because it's in the intersection. It's where the sets overlap. Now notice it's in the circle of big A and it's in the set of B. Okay, let's look at the next one. I see a B in A. Okay, I see this B in A, but it's not in B. So if I were to put it in the Venn diagram, I would write my B out here because it's not in the set B. It's only in the set A. All right, now let's take a look at the next one. We have a C. Now the C is in A and the C is in B. So I'm going to put that C, I'm going to make it really small because I'm going to have more sets here, would also go in the overlap or in the part that is in both sets, the intersection. Right, and I can continue. I look on and I go to D. And I notice that D is in set A, but it's not in set B. All right, well, I'm going to put it in the part of A graphically, or in the diagram. See, it's in the part of A that isn't in B. Okay, so it's not part of the intersection. Right now, I'm going to go on to the next value, and I'm going to take a look at E. All right, now I notice E is in both. Okay, so I'm going to put E in both. I'm going to really squeeze it in here. Okay, so I have A, C, and E now in the intersection because those three values are in both. Okay, I'm going to highlight them. We had A was the same, and C was the same, and E was the same, and so they are in the intersection. And then I go to F. F is in A, but F is not in B, so that would go out here. All right, now that takes care of all of the elements that are in A. But I see that there are still elements that I haven't even looked at from A that are in B. So those three elements I'm going to put out here because they are in B, but they are not in A. So that's how we would fill in the Venn diagram. We don't always have to fill in the Venn diagram to solve these, but I wanted you to see that when we look at our A intersect B, it is this point right here. It's this part. It's the part that's in both. So as an answer to this question, and it asks us, what is, or find A intersect B, we will write our answer in curly bracket. That means it's part of a set, right? And the set contains those three elements that are in that yellow overlap, A, C, and E. Then close the curly bracket. So we could actually, this set could have a new name. In the question, A is the name of this set, A, B, C, D, E, F. B is the name of this set, A, C, E, G, I, K. And likewise, we can say that our new set is named A intersect B. Now, like I said, just briefly, we don't have to write a Venn diagram to help us solve. It can just be helpful. So for the next example, what I want us to do is not use a Venn diagram. Well, or maybe we can't. No, actually, I'm taking that back. We're going to write a Venn diagram because I think this is an interesting example. All right, so for this Venn diagram, all right, so I'm going to write, here's my A. I'm going to label it A. Here's my C, because I want to know what's in A intersect C. That's what I'm looking at. So the first group is A, the second group is C, and I'm going to say, okay, this is equal to. All right. So I look for my elements in A. I'm comparing these two sets now, the set named A and the set named C. And I look for A. As I start with A. Okay, this A is not in at the set C, so it's going to go out here. Then I look for B. B is not in C, so that would go in the part of the circle that is A, but does not touch C, or isn't in the intersection, not common to C. We can look at C. Okay, there's no C in the set big C. Okay, so we put C out here. I look at D, and D is not in the set C. I look at E, and E is not in the set C. And I look at F, and there's nothing there that is in common. Okay, now I'm taking care of every element that's in A, and none of it is in C. And if I looked at the set C, G, H, I, J, K, none of those elements are in set A. So I would write them out here, G, H, I, J, K. Now the intersection of these two sets is this piece here. And you'll notice it's empty. They have, we would say, nothing in common. So how do we write that set? Well, there is something called the empty set. And the empty set, we could actually just write those curly brackets and they're empty. That's totally okay. We have a special symbol. You could write the word, by the way. You could write empty set. Okay, or you could write the symbol with a circle with a slash through it. And that is reserved for empty set. So you have 3 different ways to express this answer. You know, you can pick your favorite. I would say for now, this just stating empty set is probably the best thing to do, because in your next math class, excuse me, I would say that that is most common, right? So we can look at sets of elements, which could be lots of different things, and look at where they intersect. Let's take a look at a different way to represent sets, all right? And that is using inequalities and set notation. So given the sets, set A is equal to, and how we say this is the set of all x. That's the variable we're using. That up and down line means such that, and this is the piece right here. This is the piece that describes the set. X is less than 3. So set is all of the values less than 3. We have our set B. All right, B, we would read this as B is equal to the set of X, so all values, such that this part here describes set B, such that X is greater than or equal to -2. And then we have set C. And C is the set of all X such that X is greater than or equal to 5. All right, so C is going to be all of the values that are greater than or equal to 5. Now we look at the first question, and the first question says given the sets, it should say find A intersect B. So we want to find the values that they have in common. To do this, since we're looking at inequalities, and when we looked at inequalities before, we used number lines to describe them. We're going to do the same thing now. So I'm going to draw a number line. And I'm going to, here's my 0, 1, 2, 3, 4, and I'll do 5. Okay. And then -1, -2, -3, -4. All right. Now the first thing, since I'm looking at A intersect B, I'm going to look at the sets A and B. And I'm going to use a line to describe each set. So the first set is that X is less than 3. Now, less than 3, I am going to use an open circle. because we don't include 3, and my line goes to the left because it's all of the x values that are less than 3. All right, next I'm going to go to B. Focus on B. B is all the values of x that are greater than or equal to -2. So with that, greater than or equal to, I'm going to have a solid line, right? There's my solid line, and it's going to be all of the values that are greater than -2. Excuse me. Now remember that we want the overlap, right? That's what we're looking for, is the overlap. Where do these lines overlap? Well, they start overlapping, if you look at this, at -2, and the lines shade or go over the number line all the way into 3, but we don't include 3. We don't include 3. So what we can say with this is that A intersect B, excuse here, it's not an A, I should be writing an upside down U for that intersect symbol, is equal to, and we'd use the notation that they do, okay, and write the inequality. So we're going to start at -2, which is less than or equal to, this is where our x is, everywhere in here. That's where the x is. So it's less than or equal to x, which is strictly less than a +3. And this would be our set. That would be the solution. That would be the solution. Any questions? Okay, so it all starts with a number line when you have your inequalities. Let's take a look at the next example, number 2. It says A intersect C. Now I see that they are inequalities, so I'm going to go ahead and draw in my line. I'm going to label it. Okay, put a couple negative values in. And the first thing I'm going to graph on this line is x is less than 3. All right, so it's less than 3, so here's my 3. It's strictly less. And then I'm going to draw, where does it go? It goes to the right here, or to the left, sorry. And then I'm going to shift my focus, and I'm going to look at C right here. For C, it's all of the values that are greater than 5, greater than or equal to 5. So I'm going to go ahead and greater than or equal to, I have a closed dot because we include 5. And then it's greater than or equal to, so I'm going to go to the right. Now, remember that when you're doing intersect, it is the values that they have in common. And when I look here, what do they have in common? Nothing. Nothing. They have nothing in common, and that's okay, because that tells us for an answer that it is, their intersection is the empty set. You could say their intersection is empty with the curly brackets, or their intersection is the empty set. Okay, and that's totally okay. We're just trying to answer the question. Okay. So that's intersection. That was the new notation that we have. And we're going to leave these examples for Tuesday as a review. Come back and finish this on Tuesday. And I want to go over a little bit more information. Hold on. And I want to talk about union of two sets. Union. Okay, so the union of two sets. We talked about intersection, which is what they have in common. But the union of two sets, A and B, is the set of elements that belong to either of the sets, either of the sets. So it's everything together. Okay, so A union B is denoted by this symbol, A union B. So this one is like a capital U. Okay, it's a really smooth capital U, and what it means is the union. It's everything that is in A and everything that is in B all together, the whole thing. So when I look at the first question here, they give us the sets, and they're the three same sets that we had before. And I look at A union B. I'm going to write, well, we can do the Venn diagram for this one. We'll do the Venn diagram for one of them. And here is A, and here is B, A union B. And I'm just going to plop these in like we looked at before. They had A in common. They did not have B in common. So I put that outside. They both had C in common. They did not have D in common. They had E in common. They did not have F. And as far as with set B, A, C, E, they had G, I, and K. So for the sets, what I will do is I will write everything there is in that shaded area. It's just putting all of those elements into one set. Now, where there would be a repeated element between set A and set B, we only write it once. So I would write my answer is A, B, C, D, E, F. Okay, that's the whole set of A. And A, B, E, or A, C, E, then G, I, K, and then close the set. And this piece here would be the new set, A union B. We just put all of the elements together. Now, if we were to look at the next question, and here it says A union C. A union C. Okay, well, we can draw this one up as well. We already did these sets once. So here's A, here's C, and what I remember from A and C is they didn't have any elements in common. So, and I can look at what we have up there as well. They do not have any elements in common. So this is all of F. There's nothing in the intersection. That's fine. G, H, I, J, K. Okay, but it's not about, when you're looking at a union, it's not about what they have in common. It's just everything that is in A or C. Okay? Everything that's in A or set A or set C. So if I was to write out this solution, it would be A, B, C, D, E, F, and then from C, G, H, I, K. And that would be the whole answer for A union C. Sorry that got messy. But that would be everything. So it's everything that's in A or it's everything that's in C. So let's take a look at using this with inequalities. Now we use the same approach with our inequalities. And so we will use a number line. Okay, because I see it's A union B. And so I'm going to graph these numbers on the same number line. And A union B. So I'm kind of looking at what kind of numbers I need here to draw my number line. And then I will start by graphing A. And A is all the values that are less than 3. All right, well, All the values that are less than 3, I don't include 3, but everything to the left. That's where I go less than 3. All right, then I'm going to go ahead and graph B. And B is all of the values that are greater than or equal to a -2. So I'm going to put a closed dot at -2, and it's everything to the right. Okay, well, if I look, and remember, I want everything that is covered. Right? It's not what they have in common, it's just everything in both. And when I look at it, my line goes to the left here, and it goes to the right in this direction. So it covers the whole number line. It covers the entire number line. So how would we say this? Well, what we would say is that it's equal to all real numbers. That's one way to write it. And if you think back to what we did with inequalities, we could also say it is negative infinity to infinity as our answer as well, because it's everything, everything. Let's take a look at number 2. And with number 2, we have our number line because we're working with inequalities. All right, I'm going to just write the values that I need here to represent the 2 sets of numbers, which are described using inequalities. And the first one I'm going to look at is set A, and everything that is less than 3. Okay, so open circle. Let me do I like different ink with these. I'll move into the left. And then I'm going to look at group C, right, or set C, and it's greater than or equal to 5. All the values greater than or equal to 5. So we include 5, and it's everything to the left or to the right. So we can write this in a couple of different ways. If we're going to use set notation, you start like they did with the set of all x such that, and then start from left to right. And here, the arrow points, this is where x is in this area. So the set of all x that is less than 3, or, so or is the word that goes with the union, not and, it has to be or. And x could also be over here to the right of 5, or x is greater than or equal to 5. And this right here would be the answer. Now we did look at linear inequality or these number lines before, or did we? But we can express each part using an interval. And so a way to do that is describing this red part. We could say negative infinity to 3, not including 3, right, that parenthesis, and then we could say union. So we'd use the same symbol. We'd use the symbol here that was used for A union C. We could use for the answer. And then you'd have to start with the second line, the green line, and we'd say, okay, well, I'm going to include 5, and I'm going to go to infinity. You can express the answer either way. The first way I expressed it is known as set notation. It's in yellow. And the second way would be an interval notation.